Fortunately, I think we've done some work on data privacy to make that a little bit less invasive than it was back in the kind of those new days when we are just trying to figure out how to make political data work. But yeah, there's just that activity and understanding of just the pure data and kind of the second and third order analytics we were able to do from that was really fascinating.
This episode of Ken's Nearest Neighbors is powered by Z by HP, HP's high compute, workstation grade line of products and solutions. Today I had the pleasure of interviewing Hyoun Park. Hyoun is the CEO and founder of Amalgam Insights, an industry analyst firm focused on managing data and the finance of technology at scale. Over the past 20 years, Hyoun has been at the forefront of trends such as Moneyball, social networking, bringing your own device, data monetization, and the subscription economy, working with startups, large enterprises, and the investment community. Hyoun has been quoted in USA Today, the LA Times, Barron's, and a wide variety of mainstream and technology press sources. Although he primarily works with enterprise technologies, Hyoun has a soft spot in his heart for new and innovative technology startups and is dedicated to supporting greater gender and cultural diversity in science, technology, engineering, and math. Hyoun has an MBA from Boston University and a bachelor's degree in women and gender studies from Amherst College. In this episode, we talk about how data has been applied across the wide range of industries that Hyoun has worked. More specifically, we dive into the unique applications of data in politics and sport. I hope you enjoy this interview. I had a great time talking with you. Hyoun, thank you so much for coming in and chatting with me on the Ken's Nearest Neighbors podcast. I got first introduced to you in the Dedicated conference that I also spoke at. And I just really loved your story, your ability to apply data across a bunch of different domains. And you have a also really incredible story about how you've gotten into the space, where you started and where you've found yourself these days. So again, thank you for joining me. And I'm really excited to be able to kind of explore your background with everyone listening.
Oh, it's my pleasure. It's always interesting to talk about data. It's this weird world that we're in now where everything is supposed to be data driven. Everything is AI. Everything is smart this and Internet of Things that and blockchain this and Bitcoin that. But behind all those buzzwords, all of that just a lot of it comes down to data and understanding how that works and all the different perspectives that are needed to make data work. And it's been really interesting to see how that's changed over the past couple decades.
Well, it's funny you should say that. I remember when I was doing business school, one thing they always said was, or they were starting to say, is that every company is a technology company. Mm-hmm. That was something that was becoming mainstream 5-6 years ago. And now we're at the stage that not only is every company a technology company, but every company is either currently a data company or they need to become a company that manages and uses data effectively to be successful to compete in this day and age. And so, across many domains, across pretty much everything we can think of, this is just becoming more and more important. And I love that you've had so many experiences across different domains to be able to tell kind of that story as well.
Mm-hmm. Yeah, like that battle for context has been really interesting to see. How do you understand your customers? How do you know what to do next? And when I got out of college 20 some years ago, we had these like predictive analytics solutions, SPSS and SAS. And if you really, if you had a master's in math, basically, if you understood how to build algorithms, if you understood statistics and calculus and your linear algebra and all that, and you could learn to do everything from scratch. Sure, you could model decisions, but if you're anybody else, you just couldn't get into that space at all. Like the idea of being predictive was just not realistic back then, and it's been really great to see how that has really progressed over the years to the point where we expect things like natural learning and algorithmic logic to take over for a lot of decisions that we make. And it's just normal. We have some at least gut understanding of how that works, whereas 20 years ago, that just was not a thing.
Absolutely. And that is a perfect segue to, thinking about your history and your past and, 20 years ago, however long it was. How did you first get interested in data? How did you first like find yourself kind of starting to look into this domain? Was it a pivotal moment where you're like, wow, this happened to me and I love this now? Or was it this slow transition or slow learning process?
So, although over the years I became a DBA and now I'm an industry analyst looking at analytics and data management, it didn't start that way. When I came out of college, I had backgrounds in two areas. One was computational chemistry, where I had done some work on shaping molecules, trying to figure out potential drug strategies, none of which worked, by the way, or else I would probably be a chemist. So that was one area where we had very specific software that did all the math and calculated all of that for you. And then the other side was women's studies, which was a very multidisciplinary study, which I'm sure we'll talk about later. But for now, let's just leave it at that. So when I got out of college, I had a lot of research knowledge and some mathematical knowledge, but I didn't really understand this whole thing about data. I didn't take data structures. I didn't take computer science. And so I started working just normal, I would say like customer service jobs, billing jobs over the first couple of years. And I started realizing all the things that we were entering in the computer, everything we collected, everything we analyzed was data. Everything was a 1 and a 0. Everything was a check mark or not a check mark, or a text string of a certain type that could be analyzed this way and that. And I became self-taught in data over several years. So I didn't take the formal route to getting into data. But ironically, I understood analytics from my computational chemistry background. I understood a lot about metadata from my research and my women's studies background. I just never had learned the data side of things. So, I really did this inside out from the way that most people go about this.
That's incredible. I think that it's it's becoming more and more common to mix disciplines, and that's essentially what data science, what this domain is. It's a smorgasbord of statistics and computer science um, and business intuition, as well as whatever special sauce you have related to subject area domain.
Yeah.
And it's awesome to see that two things that are probably about as different as they could be, women's studies and computational chemistry, they could find at least some overlap or some intersection in this other domain of data science, data analytics, whatever it might be. To me, that's a really fun thing about this field is I would argue you could take almost any domain and find something in it that would at least be on the fringe of the data domain. And
Yeah.
there's something incredibly powerful about that to me.
And one of the coolest things I think that had happened with data science as compared to analytics is that when we moved to data science, suddenly that context and subject matter expertise started becoming really important because you had to dig really deep to be able to find insights and to figure out what was going to happen next. Like you don't find a new cancer drug candidate unless you really understand, or at least your algorithm really understands how cancer is currently being fought, in a specific cell or in a specific organ or what have you. And I think that understanding led to a kind of renaissance of understanding of the importance of metadata and being able to make these connections and being able to work with your call it line of business or subject matter experts to a greater degree. Whereas I feel that when I was working on the data analyst side, I could get away with just going into call it an enterprise application database, getting the fields and kind of pulling out reports that would probably be 95% of what somebody wanted without having any idea of what they were really looking for. And I never had to dig deeper in that way, the way that data scientists routinely have to do.
Absolutely. Well, let's take off from, for example, that role you were in. How did you go about developing yourself in this domain? And can you talk a little bit about how your career has unfolded to this point?
Sure. So my first couple years out of college, my first job out of college that I got paid for was literally picking up the phone and saying,
What
"Hi,
didn't you
thanks for
get paid
calling the
for?
phone company. Would you like caller ID with that? would you like to shut off your service? I was that person on the other end. That was literally my job. And then at the end, I would type in my notes from each call and say whether this person was whatever, happy or sad or whatever. And from that, I went to a training role. And then I trained people well. So people wanted me to start developing the back end system, the customer relations and billing systems that the experience that the agents would actually be using. So I moved in from the front end to the back end. That was probably the most important aspect of getting into data, because that once I understood that there was a back end to everything that I was working with, that's when it became really interesting. And I realized that there were all these tools or scripts or coding languages that I could learn. We didn't really have great libraries back then. This was early 2000s, but being able to at least pick up that book and learn about, call it Oracle 9 or SQL Server, whatever old databases we had back then, and just really get into how these things were structured, understand schemas, understand that there were ways to make data more efficient. That was just like magic to me. Understanding it was like being the wizard, the Wizard of Oz, except with actual power. Like you're behind the curtain, you're pulling all the strings, and then like whatever you set up is what everybody else has to work with. I thought that was really fun as a concept. And then once I understood that structure, I was able to bring all the math back in and actually understand what I was calculating, and go all the way back to the field level, go all the way back to the data lineage and the data governance, and understand, am I using data that is actually good or bad when it gets out to the math perspective.
There's a lot of things I really liked about that. So the first is, I think that anyone, if you're good at your job and you're moving up through the ranks, there's going to be a certain point where you have a head on with data, where you're going to say, okay, this is part of my life, whether you're training and you're evaluating how people are improving after training, whatever it might be. If you're good at your job in almost any role, you're going to reach this point where data is going to be useful to you. And probably even in the role that you're in, even if it's in, individual contributor, if you're making calls, whatever, data is still going to be useful to you there. It's just a different type of useful. The other thing is the magic that you described, is that you can sort of see what's going on and you're part of this system. For me, that was such a huge epiphany moment. I realized that a lot of the things that I didn't understand about technology, I was starting to get a feel for. You start to realize what's possible. And this is like a weird quote from David Goggins. I'm not sure if you're familiar with who he is, but if you shut your mind off and you don't think something's possible, it's completely undoable. I mean, that's been said for generations, whatever it might be, but you start to realize what's out there. You start to realize that, hey, these systems, they're not overly complex. I mean, some of them are very large and vast, but if I understand this, what else could I understand? What else could I build? What other capabilities are there out there? Once you start pulling on that thread, to me, it opened this entire new world where I felt like, I was looking through one eye all of my life, and I suddenly opened the other eye and realized that there was so much more out there. Maybe not to like life and all those types of things, but once you realize that like this domain is so big and so vast, one, it can be scary, but the other side of your brain is going, what could I do with this knowledge if I learned it? Like, what could I understand? What other capabilities are there out there? And I don't know about you, but I found that to be just one of the most empowering things. I just realized that, if I learned a skill set, if I understood this better, what couldn't I build?
Yeah, and I always enjoy things that are done with a lot of skill. So I'm probably the minority on this one, but like when I watch a magician, like I actually want to know exactly how the trick worked, and it makes me enjoy the trick even more because I realize everything the magician had to do the sleight of hand thing, to move your eyes this way while going this way, to make you say the number 6 even though you had no intention of saying that, to make you pick the card in the deck that is going to be the right answer. Like I love seeing how that happens, like the process. and not only process, but then also the, call it the front end, the patter, the misdirection, all of that, I find really interesting. And maybe that's part of why I find data so interesting, because the data is the magic that happens. And then I think of like literally everything that happens on a screen, literally everything I've ever seen on a computer, it just goes back to some data and some code. Like somebody wrote that. There's everything else that you experience, like just came from some data and some code. Like, and it's just a matter of figuring out. Yeah, some of it's millions of lines of code, but you started with your one line of this and one line of that, and you just moved from there. Like I find that just amazing. It must be like, I'm not handy at all, but I imagine people in construction are like, yeah, I've got like concrete and bricks and I can build anything. I'm like, I can't build anything, but I do know how to do that digitally.
Well, I really like the magic metaphor when it comes to data science, because what you described, what a magician does, is what a data scientist should be doing. It's not that you're fooling people, but you're making something that is unbelievably complex. A magic trick usually is about sleight of hand. It's about creating distraction, like learning who you're performing this on. But it's also this usually there are like red herrings, and there's alternate routes if something doesn't go according to plan, right? The best magicians, they have 3 or 4 things, or maybe even more, based on the different scenarios that could happen if they don't pick the right card or whatever that might be, right? And that's what makes the trick complete. And the same thing for any of the data work that we're doing. Like our goal is to provide some value or some show, or to make all the complex stuff that we're doing seem really simple and straightforward and making a decision. But we also have to think about, okay, how is the person that we're presenting this to going to take this? What are their next steps going to be? How can we anticipate what any of the challenges or the pushback that they're going to give are going to be, and how do we create the optimal solution for them and create the best experience for them? And you could even extend that further into what is user experience. So we have to make sure that we're doing that, a lot of those exact same things.
Sure.
But it's fun to think about this profession in the lens of a lot of these other things that a lot of people might think are a lot more thrilling. Like a magic show, most people the general population would say, oh, that's so much more exciting than what a data scientist does. But through my eyes, it's very similar, right?
Yeah, absolutely.
Awesome. Well, we kind of went off tangent there, but I'd love to kind of reel it back towards the career journey that you've been through.
Yeah. So I got into data from this, phone company background. And after about 5 years of doing that, I actually got the opportunity to work on a political campaign as a volunteer. And, we were working for a candidate guy named Sam Yoon. He was ended up being the first Asian American city councilor in Boston. And after he got elected, it was so funny. All of us were new to politics, and so we didn't understand how this worked. So, he basically got elected, and then he brought on, call it his top 4 or 5 volunteers or staffers onto his city councilor staff. And then they realized that none of them could be the treasurer for Sam, because they were now city employees. Like, they were so green that they hadn't even thought this out beforehand. So they had nobody handling the bank account and the donations. And basically I got asked, hey, do you want to be the treasurer? And I'm like, well, I understand how data works and I can, fill out a checkbook. So I figure, why not? So I did that for a couple of years, and it was really interesting to get into understand the government side, understand how campaign finance worked at a statewide level. But more importantly, from the data side, was the donors and the voting. So on the campaign side, every time you've ever gone to vote, that's a piece of data, and it's publicly available. And around 2000 or so, the political parties started understanding this and digitized all of the voting records throughout all of American history and made that available as a database. And of course, every political candidate wanted this immediately because, with that access to data, you can understand You just look at a name and figure out, okay, they voted 18 times over the past 20 years. They have always voted in the Republican primary, or they have always voted in the Democratic primary. And then, in that household, this person popped up 8 years ago. So that person is probably either a spouse or a child. Like, you can dig up basically their entire family history within these voting records that are public record. And like, we use that data heavily in the political process. And this was 2004, 2005, even before social data existed. Just using that activity data, we had that. And then the second piece of data that we had is that all of your campaign donations are also public record if they're over a certain amount. So of course you would string those together and start understanding, okay, when are you giving money? Is it related to certain time periods or certain elections, or even certain issues politically hairy political issue comes up and these people, rush in to donate. Like, all of that was already being done 15 years ago. And that was a real education in understanding how deeply you can get into people's lives with data. Fortunately, I think we've done some work on data privacy to make that a little bit less invasive than it was back in the kind of those new days when we're just trying to figure out how to make political data work. But yeah, there's just that activity and understanding of just the pure data and kind of the second and third order analytics we were able to do from that was really fascinating.
I mean, that sounds like I don't want to say a treasure trove, but it sounds like a just fascinatingly vast amount of data that can be unbelievably useful within a specific domain. And I also like how you kind of found yourself into that specific role by accident and getting access to that almost by accident. I think that looking back on it, to someone untrained, they'd probably say that your story is like, oh no, like he clearly thought this all out going through it. I mean,
Mhm.
he got to where he is. And correct me if I'm wrong, but that generally wasn't the case. It seemed like you followed things you were interested in, and to this point at least, the data just was a part of everything. Or if you looked at it the right way, it was a part of everything that you pursued.
I will be quite honest. The first 5 or 6 years after college, I was very lucky in that, as a call center guy volunteering on a political election, like, neither of those are directly related to data at all. I do think that the one gift that I had was that I found myself drawn to the data that existed wherever I was. Like, that's one thing that I did well. Everything else I did really poorly. If I had thought this out, I would have definitely taken some data structures and classes. I would have gone past calculus in college. I would have done all sorts of things differently. Um, but things will work out sometimes if you get lucky, find the right thing, and put in the work.
Incredible. I want to dive more into what happened next, but I'm feeling myself wanting to go on another tangent about
Sure, sure.
politics and the data that's being used there. I think that that's something I'd really like your perspective on is in, for example, 2016 and 2020, data is the forefront of what we're talking about in a lot of these elections,
Right.
how campaigns are using ads. And I think a good example is in 2016, the Republican Party spent, 5x or 4x or something like that
Hmm.
uh, on data and on digital advertising. And then in 2020, they spent, I think the Democratic Party spent just a little bit more in that domain than the Republican Party, really evened out, caught up. Um, I think I probably don't have the best take on this, but I look at the data and those things. I think there were definitely some unethical things going on, but I sort of also look at it like a competitive advantage. I
Hmm.
also think that there's lines that we probably shouldn't cross related to data projections um, and misinformation and those types of things. My thought is, where do you feel that line is when it comes to people's data and using data as part of a campaign or marketing tool? And then also, like, where does that all lead? Is it just going to be in, 2024, both parties are going to spend, instead of $3 or $4 billion on it, like $10 billion, and then in the next election they'll spend $20 billion, or like, is there something that needs to be done in that interim? That very loaded question.
Yeah,
So
but it's one that I've definitely thought about because when the Republicans came in with digital spend in 2016, as a disinterested, as a neutral analyst, I thought that's brilliant. You are going directly to people where people are, and frankly, I think the Republican message speaks better to emotion. There's a gut feel to the Republican message that the Democratic message doesn't hasn't quite mastered yet. Like if you're voting Republican, like there are certain gut things that you believe in. Whereas if you go across the Democrats, is there a gut thing that they all believe in? Maybe not so much, because there's this combination of different belief systems that are there between the moderates and the liberals. I feel. So I thought, they have a good message. They have a strong message. They know who they're targeting. Digital allows them to specifically target the age group and often, states and ethnicities and things that might not even be legal to do in other
but it's very
advertising
efficient.
platforms.
Yeah.
Yeah. And, they were able to just go after that. Now, I think part of the problem is that with digital platforms, you can target your audience probably a little more than should be legal from a privacy perspective. Um, it's like if I don't collect your address, but I know your latitude and longitude to, like 6 digits after the decimal point. Yes, I know exactly where you live, but I didn't collect your address. That's kind of the digital story. We have all these digital things that allow you to pinpoint exactly who somebody is, but without connecting their address or technically collecting their gender or all these other things. You don't need to because you already know, like, well, if you're buying, say, sanitary products, you're probably a biological woman, so you can, start, flooding your marketing based on that. You never asked them what their gender was. And yeah, my
We can
gender study
predict it
site
pretty
says
easy.
there are also all sorts of exceptions there. But ignoring that for a moment, there are all sorts of ways to detect data without directly asking for it that are digitally allowed right now that aren't necessarily allowed to do so. Um, that said, I have to think there has to be some sort of limit to how much you can spend on a political election before it stops being effective. I don't know what that number is, but even just looking at the last presidential election when they were spending something like $100 million in Wyoming, I'm like, come on, why don't you just like give each voter $500 to show up? Like all I know that's bribing and that's not legal, but at that point, when you're throwing that much money, that's basically what you're trying to do. You're basically trying to bribe your voters to show up. Because why else do you need $100 million in Wyoming to let people know that an election even exists? That they know the election exists. They are sick and tired to death of hearing about the election. Like that. The last $90 million, say, had nothing to do with educating people. It was just about trying to get people to the polls by hook or by crook. So I have to think that at some point, I don't know, is it $1 billion? Is it $10 billion? Like at some point, like you just have to reach your asymptote of diminishing returns where it just doesn't matter anymore. And I'm hoping it's soon because I think everybody gets sick of political ads by the time you get there.
Well, yeah, and
So yeah.
I also think that a lot of the companies that are serving those political ads have a lot of introspection to do. You
Mm-hmm.
know, it's kind of one of those things where it's a should we be doing this, or if we are doing it, how do you regulate it? There's so many challenges and questions associated with those things. And obviously Twitter has taken a pretty hard stance. I don't know if that's the correct stance or not, but it's also a very it's not a black and white area, and that's what makes it such an interesting problem, but that's also what makes it really scary. If you think about all the money that was pumped into digital advertising or just advertising about an election in general, I always think, what other good could have been done with that money?
Mm-hmm. Yes.
And it always gets me just a little bit upset. um And so, it's I don't think that that's something that data science in the short term is going to solve either. Is, how do we make elections or whatever it is more efficient? Because uh, that's a very hairy animal, and I understand
Yeah.
why governments and politics and those types of things exist. But we also, I think, have to be introspective about, okay, is two-party system, or is the way that we go about this, and we're stuck with it, we're gonna, like, there's no foreseeable future where we don't have those things. But how do we maintain or do whatever it is with advancements in technology? I mean, the way that politics is structured, it was not designed for social media, right? It was not designed
Mhm.
for this mass publicity. It was designed for, smaller groups of people to make decisions as representatives of the whole. And I just find it so fascinating to see the clash between systems that have been around for, long periods of time and new technologies that are coming out.
Yeah, and I so here's the problem. Like I think we need an army of data scientists to unscrew up digital data by looking up things like they might be as simple as if your gender is typically male or female, what are the things that are call it 90, 95, 99 percentile in agreement with that are basically predictive of that without stating that. What are the data signifiers that are being used as a coding basically or redlining from a digital perspective, and then actually making sure you don't do that because it's not ethical. Like there is a important job to do there, but it doesn't pay any money, and there's no political will from either party to take it on. It would need some sort of Wikipedia like social wave to take over and do something like this, which I honestly don't think is going to happen. But it is something. It's something we need, but it's a totally unfunded mandate.
Yeah, it's also a cat and mouse game, right? Because, we redline certain things, and then you have something that comes around that technically isn't that. And we're always inventing new ways to just get around rules. It's like hackers, where once you find, you cover up the vulnerability, they find another one, and you're always chasing. You're not. It's very, very difficult to be proactive in those domains, which is very frustrating from what I believe and see.
Yeah, and I worry about that a lot because there's this next generation of data governance that we have to think about now. Where do models pull their data from? And as models change, as features change, um, and you go to new data sources, you now need to know the lineage of that new data source that you worked with and how those changes might have historically affected your results or who is placing the inputs, things like that. And I'm not sure that our data governance can keep up with the agility of the changes and the resulting outputs that we get for rapidly changing models. Um, you know what? Hopefully, there's a new generation of governance and lineage that really ties all this together. But I think that for right now, we're in this intermediate period where we're in this period of flux. Quite honestly, where we have too much data, it's going too fast. We haven't quite figured out how to manage it. We can do it at micro bits for specific problems that we're trying to solve, but we don't have a full ecosystem of fully trustable and interchangeable data that like we'll be able to put into that we can consistently count on. I feel, and that's kind of a challenge.
Well, honestly, that's something I think about a lot in regards to my work, in regards to entrepreneurship. It's very strange, but I feel like these days, companies that are founded right now,
Mhm.
they, in some sense, have a very unique competitive advantage where data is growing at such a large volume that they're creating systems to scale, they're creating governance structures that are built for massive growth. Whereas companies that have been around for longer, maybe even just 10 or 20 years longer, they're finding that the systems that they built can't sustain the data growth and the new models and whatever it might be that are coming out. And so it's a good thing and a bad thing that companies related to change management and data, I think, are always going to be in business.
Hmm.
But it's unfortunate that you might have just hit this time wave where it was a good decision at the time to make a certain decision regarding data and infrastructure. And the pace of technology has just grown beyond what the feasible solution you created back then was. And I guess that
Hmm.
that's like kind of, again, this ongoing problem where companies will either have to figure out how to be agile, they'll shut down and new ones will start, or they're just always going to be chasing. And I guess in theory, companies are always chasing something. And maybe once you reach a critical mass, that changes a little bit. But it's a very fascinating business problem to me, from like the business brain cells and the data brain cells working together in my head.
Hmm.
And um, I don't know. I don't think there is an answer, but it's something I think everyone should think about, is if they're an entrepreneur, if they're a data scientist, like, are we just going to be running? Are we just doing this process, or is there an end, or is there a right time to start? Probably
Yeah, I
not.
worry most about like the things that you're locked into. Either the sunk costs or the systems or the processes that you can't move off of a specific system. I can say this now that I've been away from Bose for over 10 years, but when I was there, we had certain processes that were working off of an application written in Fortran. And this was like 2009, 2008. Long past the time when anything should have really been running on Fortran. Like we didn't even have a developer on staff who could like fix anything if there was a bug or if we needed to add new types of payments to the system. Like it was that old. It was an application called Man. I think the first ERP ever created. Um, and just having a mission critical cash payments that are reliant on an application that's 40 years old that you can't even fix or patch in any way is troublesome. And not that it's most companies are quite that bad in 2021, but that still that issue exists. Like we have this huge data center, and we have nothing to run on it. Like, what are we going to do? Do we keep it? Do we not keep it? All those types of things that you do with legacy technology or with legacy processes or legacy thinking are potential challenges to the business.
Yeah, well, it's funny, in this conversation we're hitting on a lot of my business side, not pet peeves, but things that I care pretty deeply about. Something that
Mm-hmm.
I see, especially in larger organizations, is you have more of these legacy systems because the cost of covering them up, the cost of renovating or changing or the digital transformation is very high. And if you're looking at costs and revenues on a quarterly basis, on a monthly basis, in these short time horizons, which is what large companies do because they have investors, you almost never make these sacrifices that would pay dividends in 4 to 5 years, because you care a lot about the quarterly profits and being responsible to stakeholders, shareholders, whatever it might be. And I think that that's so inherently flawed. To me, I mean, I consider myself an entrepreneur,
Mm-hmm.
and it would kill me if I was thinking about everything on a month or quarter basis, because, you know, like, you have to think about the future, and the bigger you get, the shorter your future window becomes. So maybe I'll get off my soapbox, but that's my pitch for for the entrepreneurial mindset, the longer term thinking, because that's where you make real difference, right?
Yeah, I my first 4 years as an industry analyst, I worked at the Aberdeen Group, which at the time was a subsidiary of a publicly traded company called Hard Hanks. So because of that, we all had our revenue numbers that we were supposed to hit, and every quarter we would do the stupidest things to bring in one last deal in before March 31st or whatever, because that was the number that our stock was going to be judged on, like in a month or so when we did our earnings call. So that would we did stupid things all the time that made no sense from a long-term perspective. And just the idea that and I'm sure we weren't the only ones that did it. I'm sure every publicly traded company that doesn't have $250 billion in the bank like Apple
Like
does,
Apple, yeah.
probably does the same thing. But yeah, it's just a frustrating way to run your business, because it has you make so many decisions that aren't good business decisions. Nothing that you learn in MBA school or when you're learning in college.
Well, it's interesting to that point. I think that that directly conflicts with data science and
Hmm.
this specific domain because data science projects don't pay off quarterly
Hmm.
for the most part. I mean, some of them can, but I think truly impactful data science projects pay off after you've built models, you've trained them, and they've gotten more data. And data can take a lot of time to aggregate and to develop. And if you're thinking about data science projects in the span of a couple months, even if it's half a year, you're missing out on a large part of the upside that can be done. And so,
Hmm.
when companies get into this quarterly mindset, it makes it creates a ton of friction for the data science teams because you're not seeing these great results right off the bat, unless you're really picking off low hanging fruit and doing data analytics. I think you could do data analytics effectively in that short term, but
Yeah.
um, I see it time and again when I talk to people, when I'm doing consulting work, whatever it might be. Um, that to me is just this huge problem that so many organizations are facing, and I wish more CEOs listen to this podcast because they might.
It's funny because I feel like, although I did go to B school and get an MBA, a lot of what I learned about sunk costs and investment really came from baseball. So I used to be deep into baseball statistics from, I want to say, about from the mid 90s to about 2010. And that was about the time that Moneyball started being popular. But really, the ideas of talking about on base percentage and like the money of Moneyball had existed for decades beforehand. It's just that those ideas didn't fit into the mainstream of what existed in baseball. Like you needed first one manager to come in to build minor leagues so that you would invest in the future of your company and set up players to get ready for the majors. And then once you got there, you had to start using statistics. Like somebody had to break that barrier to start using statistics, but you still had 20 plus other teams that were very invested in their gut feel and having tons of scouts who only understood the qualitative aspects of what made a player good without even understanding numbers at all. And it took a long time to like understand that some of those costs were sunk costs. Some of those capabilities needed to be augmented in some way, and that sometimes you had to invest past this season and think about next season. Like all of that seems like common sense, but for probably a good 70, 80 years, that's not how Major League Baseball worked at all. So as a kid, just learning about getting the statistical introduction to how all of that worked was really a game changer. And also learning about kind of some of these contracts, the long-term contracts that would come into play, long after a player, lost their, playing capabilities. We just celebrated Bobby Bonilla Day on July 1st, the day that
Best
the Mets
agent of all
pay.
time.
Yes, the day that the Mets paid Bobby Bonilla $1 million off of their payroll, and will continue to do so until I think he turns 73 or something. Perfect deal. Great deal for Bobby Bonilla. Yeah. So like all those things I learned from baseball, and then realized much later on, once I started getting into data, that these things had some greater business relevance as well. And I thought, wow, I'm so smart for putting baseball and work together. And then of course Michael Lewis comes out with Moneyball, and he becomes famous for it. And I'm like, well, there's no point in talking about this now, right? Because
Yeah. Well, I actually think that there are still incredible parallels that Michael Lewis doesn't talk about, where we connect management and the domain and digital transformation within an organization to what's going on. I mean, there's always going to be naysayers around analytics. There's something crazy and fascinating about creating a culture around data within an organization and instigating organizational change within that. I mean, even within the MLB, where it for most teams is obvious that analytics will help them win, you
Mhm.
still have laggards. You still have people that aren't willing to invest in the people or the technologies or whatever it might be. And you get to thinking, do these teams not want to win? And that's not the case. They all want to win, but it's, they have these quote unquote legacy systems, and the systems can be people too, which is not something we think about. And I think that, what makes an organization like a baseball team change are a lot of the same things that can make a company change. Sometimes that's a
Mhm.
leadership change, right? Sometimes that's having advocates within the organization. Sometimes that's just like a one pivotal analysis that reframes how everything works. But to that point, that story I think is still being written. I think it's still being told. It's not like every baseball team does have an analytics team now. But if we
Yep.
look across other sports, I mean, basketball, it's not true. Football, it's not true.
And then even with baseball, it's gone through multiple generations. Like I feel like the first generation of baseball statistics was measuring all the things that happened on the field and then doing some sort of math. So hits divided by at bats equals batting average, and then who has the best batting averages. And then we also included how many times you get on base, but basically measuring all the things that happen on the field and adding or dividing them in some way. And then we got to like this second generation of analytics, which was trying to figure out things like wins over replacement, like these artificial statistics that you can't measure just based on the field, but are based on regressions of like
Based on baselines,
stats
right?
to win. Yeah, exactly. So we got the second generation, and now we have this third generation where we're actually creating new kinds of data, between StatCast, the cameras,
Yeah.
being able to see ball rotation, how fast did a fielder go? Did he run 90 feet to catch that ball? And being able to use a lot of this activity and physiological data to augment everything else that we've been doing. And so now and everybody's got that first generation of data down pat. Most of them are the second. Third is still kind of, in the air, like even with the teams that all have analytic teams, they're all at different levels of maturity there as well in understanding how much data they can actually use and align it to performance.
Yeah. Well, you outlined those beautifully. I do think that there's a fourth generation coming that is even more difficult to quantify, and that's what's going on, not just physiologically, but between people's ears. So
Mm-hmm.
what they're thinking, the types of beliefs they have, what they say to the media. Can we evaluate this and help them to, or like help them to either develop a mindset or identify the mindset that elite players have that make them perform differently? I mean, you look at some press conferences, and I follow golf the most, but you look at what people say to the media or how they talk about themselves. And to me, that is like physical stuff, very important. But the
Mm-hmm.
mental side of the game is something that it's evaluated, it's looked at. We have sports psychologists, but it's not quantified in the way that we quantify almost everything else now. And that to me is probably the most difficult, but also going to be the most incredible domain if we begin to crack it around performance.
Yeah, like in golf, like Bryson DeChambeau, like he is a fascinating player to me. Somebody who's literally transformed his body to become a better player. Very outspoken. Some of his beliefs are definitely out there about
Beliefs.
wanting to live forever. All sorts of stuff. But at the end of the day, he's made himself into an elite player. But like, is that outspokenness actually better for being an elite player, or is it distracting? I don't know the answer to that, but that would be fascinating to understand because golf is, I think of it as a very mental game. Obviously you have to be strong and fast in this particular ways that make, golf athletic, but, you have to be, have a lot of smarts in specific ways, and you have to keep this neutrality. You can't have your heart beating 180 beats a minute while you're trying to sink that putt. You've got to keep somewhat calm. At least I would think. Maybe it's like here's where I might be 100% wrong, right? Maybe the
Oh,
best players are those who are like are always enraged and still manage to land everything just right. I don't know, right?
no, I think you're you're almost spot on. I mean, so golf's the sport that I competed at the highest level. I mean, I played in college. I tried to play a little bit professionally. And what was always so frustrating to me is that from a physical perspective, in other sports, I was very, like I was small, I'm like 5'9" on a good day.
Mhm.
And, that kind of cuts me loose from basketball and baseball and a lot of the other sports. But golf, I could compete physically with almost anyone out there. I hit it, I, you know, about as far as the average PGA Tour guy still.
Mhm.
Um, I have good touch around the greens. I have these types of things. But even with that, I could not figure out how to score as well as these people. I could not figure out how to be as consistent as the other people out there. And that inevitably, it's difficult for me to say, is something in my head, right? If I have
Mhm.
all the physical tools, but I still can't compete on that level, that's not a physical thing. That is a mental thing. And that's honestly one of the reasons why I have interest in what I do have interest in is, okay, understanding sports analytics. But my second biggest fascination, maybe even my greatest fascination in life, is understanding my own mind and personal development. We talked a little bit about how you have Grit on your shelf up there, and
Mhm.
it's one of my favorite books. I probably read more self-help books or more personal development books than a lot of people out there, because that's the key, is understanding what goes on in the gears in your head. And there aren't a lot of quantitative or necessarily like outside looking in ways to evaluate those things. And so maybe that's a little too much information, but at the same time, it it, it to me is like the idea that the biggest problem or the biggest world is sort of inside of you already, and the thing that there's
Mhm.
the most to explore is your own brain in combination with whatever you want to do, is uh is is powerful. This episode is brought to you by Z by HP, HP's high compute workstation grade line of products and solutions. As datasets get larger, unraveling meaningful insights can become more time consuming and costly. Z is specifically made for high performance data science solutions, and I personally use the ZBook Studio and the Z4 workstation. I really love that Z workstations can come standard with Linux, and they can be configured with the data science software stack. With the software stack, you can get right to the work of doing data science on day one without the overhead of completely reconfiguring your new machine. These powerful machines are being used to solve real world problems as well. If you're a student and you want to get your hands on one of these, there's a great opportunity right this second. HP is hosting a Kaggle competition to identify and localize COVID-19 anomalies, and the student team that scores the highest will receive a top of the line ZBook Studio. Now, back to our episode.
Yeah, and I think across the sports, there are certain players that have become great because they are able to do consistently elite things, like Steph Curry in basketball. He's not the biggest, he's not the fastest, but wow, he can shoot a three-pointer from literally anywhere on the court, and he can always do it. And that's what makes him, it's part of what makes him great. Um, you know, Being able to conduct an elite skill consistently, um, that's a real mystery. And I think understanding how that happens would be amazing to see, because I think about that even like in my normal line of work, like in doing data, working with data. Like most of us aren't held to a standard of having to execute something perfectly at the highest level of human effort, called 30, 40, 50, 100 times a day. um, but if you could somehow get there, like, maybe you could be 10 times more productive.
Yeah, no, absolutely. I think that's, there's just so much that we still don't know, and that's just such a fascinating. I've said fascinating a lot, but that's just something that it blows my mind every day.
Mhm.
So again, we went on a little tangent there, but I love that tangent about baseball. We're both big sports nuts, and I'd kind of like to pull that back to maybe the rest of your career in a condensed form, and then talk about, since you've been so interested in politics and even baseball and whatever that might be in a lot of these different domains, how did that all come together, and what have you learned? What are the similarities, the common thread that has been through all of these domains that you've seen data used in?
Yeah, yeah. So, I had about 10 years of my career where I was going back and forth between sports and telecom and politics and really getting a pretty decent idea of how data was being used. And then around 2008, I became an industry analyst, deciding that it would be great to look at the market and see all the different types of solutions that were out there, being able to provide recommendations to enterprise end users, helping the vendors to explain why their description of what they're providing was really bad and how they can improve it. All of that was a lot of fun, I thought I was going to do it for a year or two and then go back into the startup world, but I've enjoyed it so much that I've basically done it ever since, and I've spent the past 13 years basically riding each wave of data, analytics, data management, AI, machine learning, and helping companies to take that ride along with them. And the only real skill I have at this point is staying 6 months ahead of them.
I love that. And before we get into the common threads that you've seen, especially analyzing this industry for a long time, can you explain more what it entails to be an industry analyst? Are you producing reports? Are you consulting with companies? Like, what does that look like?
Sure. So the industry analyst role is about looking at software markets. Mine are usually defined as business intelligence, data management, perhaps machine learning, perhaps artificial intelligence, depending on how you're defining that, whether it's general or narrow or broad. I look more at the narrow and broad categories. I don't really look at general artificial intelligence. But basically, it's getting an understanding of the key vendors that are purchased in each of those markets. And then I have three key constituents. On the end user side, I help companies to buy solutions if they're trying to figure out something to fill out their data portfolio, or if they're trying to get a better analytics solution. Those are usually short consulting gigs. On the vendor side, I help them with messaging so that they understand what the heck is going on in the market. They're so focused on building their products that they don't necessarily understand the market at large. Even though they're experts, they're definitely smart. They know how to build their product. They're technically experts, but not necessarily understanding marketing trends. And then I also work with investors trying to figure out is this potentially a good company to put into our portfolio based on their thesis, based on what their current portfolio looks like. Often they'll be looking to make some sort of venture capital investment and want to do some sort of due diligence beforehand. So it's kind of this odd jack of all trades job where I'm providing guidance to a lot of different groups and kind of using arbitrage. What I used in the last conversation helps shape what happens next, along with, of course, keeping up with general trends in data and analytics.
With that framed, I actually, that sounds incredibly fascinating to me. I love the idea of understanding what's out there and what we're looking at next. Let's relate that sort of to that previous question of, what have you seen in this field across all these different industries and across the different time horizons? Like, where have we been, and then perhaps like what's the common thread there, and then where do you think we're going? What's the next step with your, like, yeah, I might have to pay for this advice, but like, what's the next horizon that you're seeing within this domain?
No. Yeah, I feel like when I started my working career, analytics and anything algorithmic, anything data related was extremely fragile. You were very reliant on your database administrator and your report builders and the couple of quants that you might have had inside of your company to do all of your data work. You might have had like 10 people who could do the work, analytic work for 10,000 of a 10,000 person company. And without those few people, everything completely fell apart. What I've really enjoyed watching over the years at a broad level is the increasing focus towards self-service, where people can simply choose their own data sources, create their own reports, be able to publish them, and be able to update them over time. That's so ridiculously simple that we take it for granted. But until about 10 years ago, like that really wasn't very possible. It was kind of with the evolution of Click and Tableau that started happening. But I feel like after that, the next jump that I really found important was kind of the start of data science, really, which, although it's existed for a long time in some form, I really don't think it really reached kind of maturity until 5 or 6 years ago. Really reaching a point where there was a market for the data science skill that people understood. Before that, there were needs for statisticians, but it wasn't quite the same job or quite the same demand. So that's been really interesting to see. And then right now, what I find really interesting is there's been this kind of problem with analytic adoption over the past 10, 15 years. It's hard to get more than, call it 25, 30% of your company to ever use analytics, partially because you have to teach everybody to be a data analyst. And frankly, there is a limit to the number of people in your company who ever want to learn this stuff, as cool as you and I find it. So I do find that this move towards natural language querying, kind of the Googling of analytics and the ability to be able to ask questions to data more directly, is an interesting trend that I think is really, I hope it's really going to open up analytics, because the more people who can at least get into the on the ground floor of analytics, you have to get in somewhere to be able to expand the conversation. So I feel like we can hopefully get, call it another 10, 20% of employees to get in the door to at least ask questions about data, and then they can learn from that and ask the next question and become more data literate. That is what I'm hoping happens. Whether that actually happens, I've been wrong before, but I want to be an optimist about this one.
Incredible. I think that that's something that, I mean, I'm 100% seeing as well, is that it's not that data science has incredible capabilities now. We'll have even more incredible capabilities later, but these capabilities are useless unless people adopt them, unless people buy in, unless people realize or see how they can integrate into their workload or into their life. And in my mind, the biggest challenge isn't creating the next iteration on whatever neural net architecture we have. It's getting people to use these things for a lot of the stuff that they can be used for currently. Mm-hmm. It's just essentially seeing the light and being able to integrate that into the systems that they currently have, or even taking the existing technologies and productizing them so they're viable across even more use cases. I think that, for me, I'm never going to be someone that creates a company where I'm making a new technology, machine learning wise. It's that I'm leveraging a technology out there in a new and exciting way. And I expect that that's going to happen a lot soon. But it's only a matter of time.
Yeah, there's so many problems out there being solved. One of the trends I like in the SaaS area is seeing finance people building solutions for finance, procurement people building solutions for procurement. You're seeing companies like Flowcast in accounting, Raindrop for procurement, and they're not built by developers. They're not built by even statisticians. They're built specifically by the people who did the job. So I think a combination of that and people learning data science is going to lead to another set of solutions over time of kind of these more self-learning, natural learning, natural language processing and generation applications, but also analytically smart, and just creating these more interactive solutions to solve basically every problem we have and create that next generation of applications. That it's exciting to see that there's a road forward. The work is not going to go away anytime soon.
No, I love that, and I'm very personally excited about that as well.
Mhm.
So to kind of end things off, I think it would be great to go full circle. We
Mhm.
started with you touching on that you're a women's studies major in college, and I'd love to hear more about how that's impacted you in your work, or some of the things that you've learned from that you're able to see in this community or in data science or across these different domains. I think that one of the most powerful things that we have is our the different things that we studied or learned about or that we're interested in our lives. And I always like to see how that's integrated into what we do now or what our belief structures are at a more macro level.
Yeah, so I majored in women's and gender studies at Amherst College, and they actually renamed the department recently to Sexuality, Women's and Gender Studies, which abbreviates to SWAGs. So now I've got all the swag. It's fantastic. It's probably the best investment I've ever made getting that major just to be able to connect that to my name. Uh, but it's an interdisciplinary major, which means you can make of it what you want. And my perspective of it was a combination of history, biology, and sociology, survey work. So going through women's studies, I was very interested in how gender was created as a spectrum. This was very hard to describe in the mid 90s, how male and female were two aspects of a spectrum, not just from an I want this to be true, but literally from a genetic perspective, the way that gender has been displayed across every single culture slightly differently with the types of characteristics we tend to think of as male or female. Like there have always been like third genders or intermediate genders that have existed somewhere on the earth, and just having that context of understanding that what is typically seen as binary is actually very on a spectrum, and like something as theoretically binary fixed as gender, as we learn it, call it in middle school, is actually very contextually different based on where you are, how you're living your life, what century you're in. All of that was very interesting at the time, but I didn't quite understand how that worked from data perspective until years later when I started learning about how semantic layers worked and how metadata worked to be able to contextualize data. And then suddenly, like it was like all this popped together at once, realizing, so I've got this one or zero here, but I can both contextualize it based on the field name as well as everything the field is linked to, as well as the taxonomies and ontologies that exist that are associated with each of those fields. And now I have this story that goes along with each field. And so that one isn't really a one. That one is connected to all these other things. And I feel like that mode of thinking is something that I learned from my women's studies background. So I know that's very convoluted way of getting there, but I actually think that these interdisciplinary studies are really useful for understanding metadata, semantics, taxonomies, context, and being able to do that middle layer between data and then getting to the pure algorithm or formula. It's been really helpful for me to be able to have that in my toolkit as something that is fluent and kind of always on. And we all get there in a variety of ways. That just happens to be my way of getting to interdisciplinary thinking.
No, well, I think the interdisciplinary thinking has been very eye-opening for me for the last year. So I taught a course called Designing Ethical AI Systems
Mm-hmm.
with an incredible teacher who's also been on my podcast named Oveta Sampson, and she's a designer by trade. And there was a theme that she had in the class, and the idea was that you shouldn't divorce people from their data. So if we're looking at someone, a data point, a row in isolation, and we see that, like a male female column, right?
Mm-hmm.
we're putting that person with all the other males and all the other females, however we chose to define them. And like that isn't an efficient way to find a solution. We should be looking at everything that they have together as, frankly, it's like a row or as a person, not just those things in isolation. And it's very, very easy to look at things in isolation. And yeah, like there's mixed effects models, there's things like that that help us to not do that. But we get really wrapped up in making decisions or insights associated with single variables, and that
Right.
can be inherently dangerous. And I'm talking about this, like from my data science brain, and
Hmm.
I also think that the way that we talk um, about like race and gender, a lot of the times it can be a bit harmful. I remember my first experience uh, with like sociology, for example. I took a class called the Sociology of Race, Class, and Gender,
Hmm.
and the content of the course was fascinating to me, but the teacher I had just like didn't understand math. It was like problematic because there wasn't that interdisciplinary approach. So he drew
Hmm.
these two histograms on the board, these normal distributions, and said essentially like these are men and women. There's so much similarity between these two groups. And then he says, why aren't women playing in the NFL? And he's trying to say that like there should be more women in the NFL, or they should be playing because because we're so similar.
Hmm.
But we have to think that the reason why um, the people in the NFL, they are on the so far right of that normal distribution of humans
Yes.
that
Hmm.
that they're probably that maybe there's a little bit of overlap, but the probability that there would be like a female in that distribution that is also interested in playing football and all those types of things, it's like astronomically low. And
Right.
so that was frustrating to me because I understand, or at least I believe I understand the value of like diversity, and like I also think that there's value in like slight differences among people because we have different thought patterns. We have the ability to um, come to the solutions by taking different perspectives. But it very much frustrates me when we don't look at these things, just like gender in isolation. We don't look at them as interdisciplinary problems because so much of this, if we look at it as the whole and these different systems that are put together, it eliminates a lot of confusion and a lot of the frustration that I felt in that class, thinking like he's right in some sense, but he's wrong in the use case or in these scenarios, and
Yeah, you've got this outlier that's way out,
yeah.
not even here, like here. Yeah, off the screens. Outliers that are the professional athletes. Like the one, the few women who might be able to do it might want to be weightlifters or wrestlers or something else where they don't have to hit their heads against other people.
Yeah, I mean, you're telling me like,
Yeah.
if I had the physical ability to play professional football, I'd probably choose a different sport.
Mhm. Yeah, but
But
that aside, maybe the other answer is you change football to make it more gender neutral. Like there are all sorts of different ways I feel like you can go towards gender equity without necessarily having to promote having more women playing in the NFL. Um,
I would agree.
Yeah. But that said, I did run into that problem as well. Like, I had some professors who had, I would say, strong statistical and social, like survey backgrounds. I learned a lot about survey data going through the Women's and Gender Studies program that in the way that I did it. And that was very helpful for understanding how to ask behavioral questions, how to get decent data, how to get decent survey responses, doing stuff like that. But then others might have had more of a, call it a history background, religion background, fantastic writers, fantastic at doing that, but not necessarily having the statistical or mathematical background to always talk about the way that exceptions took place. But I found that that's why uh, the interdisciplinary perspective was helpful because with the strong, let's call it sociological and biology professors that I had who understood obviously genetics and math. Being able to have that background to go along with everything else is what made it work.
Absolutely. And maybe I think I'm a little too hard on, maybe I don't want this to sound like I'm hard on the field. I think that in my specific circumstance, I saw the value of that multidisciplinary approach, and like the one of probably very few professors that I had didn't quite understand the multidisciplinary value. And to me, that's what makes all of these fields work. Like understanding data science, which again is another multidisciplinary field. Like if you don't have an appreciation for the computer science or the statistics or even the business intuition, I think that you're going to be missing something that's really important for being an effective data scientist. You don't have to be an expert in all of them, but at least having that appreciation and knowing where perhaps you have an oversight or something along those lines
Mm-hmm.
is what makes you effective. And knowing where you can bring people in or ask for help is a very, very important thing.
Yeah, absolutely.
Awesome. That is all the questions that I had. Hyun, I really enjoyed this. Any final thoughts? I'm back. Sorry, that was all the questions I had. Any final thoughts? Any parting words of wisdom that you'd like to impart?
Yeah, just one last thing that I wanted to bring up that we've run pretty long here, I know, but one of the things that I've tried to advocate for in my career, trying to bring everything together, is thinking about how to get more women into tech, how to get more girls into math and technology, especially kind of the cutoff that happens in junior high, where we seem to have this gendered split that separates boys from girls in things like honors math, computer science. Like it shouldn't be happening, but there's still that bias that definitely exists there, both in the school system as well as in the workplace. Because I know I came into data by accident. I did not call it the traditional male gendered computer science path into how I got here, and
Actually, quite
I
far from it.
yes, and frankly, I would love for there to be everyone to have that opportunity. So everybody who wants it, everybody who wants to get into tech, get into data, and just to know that you don't have to start by being the honor student in computer science. You do need to be curious, and you do need to always find the data that exists in what you're interested in or what you know. Whether that's landscaping or working at McDonald's. There's data in every single thing that we do, and it's just a matter of finding that and understanding how that job is digital and knowing that there's a next step that you can take in that direction if you want. That's a message. Those two messages, both that there's a path forward that involves data and to look diversely at potential students and potential employees and potential applicants to make sure you're not overlooking non-traditional backgrounds and looking for people who are really interested in doing the job.
Incredible. So is there a resource or something along those lines that you suggest people to look into, communities around that you think would also be helpful?
My favorite one right now is pretty well known, Girls Who Code. It's definitely my favorite community that I've been working with as of late. Just helping to bridge some of these sociological gaps that exist, and just making just putting a little more equality into getting there.
Incredible. And so my last thing is where can people find you?
So my website is amalgaminsights.com. Amalgam as in Amalgam, a mix of things. It's how I've lived my life. And insights. That's what I do and where I am.
Incredible stuff. Thank you so much for tuning in, and I really enjoyed this.
Great. It was my pleasure. Thanks so much.